Today, we will be learning how to graph linear inequalities both in the slope-intercept form and standard form. We will also identify solutions that will work when you substitute to the inequality. Question number 1. Y is less than or equal to 5/3 x plus 2. This inequality is in the format y mx plus b form. So this means 5/3 is the m or the slope and 2 is the b value or the y-intercept. To graph this inequality, we will begin first with the y-intercept 2. From the 2, we can graph the slope 5/3, which means 5 up and 3 to the side. Or you can also go 5 down and 3 to the left. So now let's connect these 3 points to graph the line. Since the inequality is y is less than or equal to, this means that the solution set will be anything below this line. So we're shading the lower half of the graph. The second method in determining which half of the line is a solution set is by using a given point. I will choose the point 0, 0, and I will plug in that 0, 0 into the inequality. y is 0, less than or equal to 5 over 3 times 0 plus 2. 0 less than or equal to 0 plus 2, which is 2. And this inequality is true. That means that anything in this shaded region where 0, 0 belongs is the solution set to the inequality. For this question number 1, there's infinite solutions to this inequality. This includes all the points on the line and below the line as well. Question number 2. Y is greater than negative 3 over 2x minus 1. This inequality is in the format of slope-intercept form, so the slope is negative 3 over 2 and the y-intercept is negative 1. Graphing this inequality, we will begin with the y-intercept negative 1. Now graphing the slope negative 3 over 2, this means 3 down and 2 to the right. Also, you can do it 3 up and 2 to the left. Since we have a greater than, that means the graph should be a dashed line. Are we shading the upper half or the lower half? We're shading the upper half because you have y is greater than, which means that the solution set of this inequality are any ordered pairs above this line. Let's take the point 2, 4. And this point should satisfy the inequality. Y is 4 greater than negative 3 over 2 times x is 2 minus 1. 4 greater than negative 3 over 2 times 2 is negative 3 minus 1. Simplifying this, we have 4 is greater than negative 4, which is true. For question number 2, the solutions are anything above the line, excluding the points on the line. Question number 3. 4x plus y is less than or equal to negative 4. Since this inequality is in standard form, the first thing that we need to do is rewrite it in the slope-intercept form. Isolating y on the left side, we need to subtract 4x to both sides of the inequality. So now we have y is less than or equal to negative 4x minus 4, which means that the slope is negative 4 or negative 4 over 1, and the y-intercept is also negative 4. Now let's graph the inequality. Let's begin with graphing the y-intercept negative 4. From negative 4, we need to graph the slope negative 4 over 1 or positive 4 over negative 1. Since we don't have space 4 down and 1 to the right, then we will go 4 up and 1 to the left. 4 up and 1 to the left. Since we have less than or equal to, this means that the graph is a solid line, not a dashed line. The inequality is y is less than or equal to negative 4x minus 4. This means that the solution set to the inequality are anything in the lower half of the line. Let's take a point in the shaded region, let's say negative 3, positive 1. Plugging in the point negative 3, 1, we have 4 times negative 3 plus the y value 1 less than or equal to negative 4. 4 times negative 3 is negative 12 plus 1 less than or equal to negative 4. Negative 12 plus 1 is negative 11, and negative 11 is less than negative 4, which is true. So the solution set of this question number 3 are anything on the lower half of the line, including the points on the line. Question number 4. 2x minus y is greater than or equal to 1. First, we need to transform this into y mx plus b form. So we need to subtract 2x to both sides of the inequality. 2x minus 2x is 0x. So now we have negative y greater than or equal to negative 2x plus 1. Next, we need to divide each of the term by negative 1. Remember that when you're dividing by a negative number or multiplying by a negative number, the inequality switches. So from greater than or equal to, we will now write it as less than or equal to. So the new inequality is y is less than or equal to 2x minus 1. So the slope is positive 2 and the y-intercept is negative 1. Now let's graph the inequality starting with the y-intercept -1. From the -1, we need to graph the slope 2, which means 2 up, 1 to the side. 2 up, 1 to the side, 2 up, 1 to the side. Or you can also do 2 down and 1 left, 2 down and 1 left. Our inequality is less than or equal to, so this means that we will have a solid line. Are we shading upper half or lower half? We're shading lower half because the inequality now is less than or equal to. So this means that the solution set of this inequality are anything below this line. Let's take the point +4, -3. Substituting for -3 into the inequality, we have 2 times x is 4 minus y is -3 greater than or equal to 1. This should satisfy the inequality for this to be true. 2 times 4 is 8, minus -3 is +3, greater than or equal to 1. And 11 is indeed greater than or equal to 1. So the solution set of question number 4 are any ordered pairs in the lower half of the line, including the points on the line. Question number 5. X is less than or equal to -3. Since x is -3, this means that this line is a vertical line passing through x equals -3. So you will have an undefined slope. So the graph of this line is a vertical line passing through that -3. Since the inequality is less than or equal to, this means that the solution set are anything on the left side of -3, including the points on the line. Let's take this point -5, +2. Using that point -5, 2, the inequality says x is less than or equal to -3. So the x value is -5, and if we substitute -5, we have -5 less than or equal to -3. And yes, -5 is less than -3. So the solution set of question number 5 are anything on the left side of the line, including the points on the line. Question number 6. Y is greater than -5. To graph this, y is -5. So this means the graph for number 6 is a horizontal line with a slope of 0. So we simply need to draw a horizontal line passing through -5, and this should be a dashed line because the inequality is only greater than. Since it's greater than, are we shading upper half or lower half? Since it's greater than, this means that we're shading upper half of this line. So in this graph, 0, 0 is part of the solution. Because if we plug in 0 to the y, we have 0 is greater than -5, and this is true. So the solution set for question number 6 are anything above the line, excluding the points on the line. Question number 7. Y is less than 8/5x minus 3. Since this inequality is in the slope-intercept form, this means that 8/5 is the slope and -3 is the y-intercept. To graph the inequality, we will begin with the y-intercept -3. Since the slope is 8/5, this means that we need to go 8 up and then 5 to the right. It is less than, so this means the graph is a dashed line. Are we shading upper half or lower half? We're shading the lower half because you have less than. This means that anything on the shaded region are solution to this inequality. Let's try the point 5, -5. Plugging in 5, -5 into the inequality, we have -5 is less than 8/5 times the x value 5 minus 3. Simplifying this, we have -5 less than 8/5 times 5 is 8 minus 3. Simplify further, we have -5 is less than 5, which is a true inequality. So the solution set of question number 7 are anything below the line, excluding the points on the line. Question number 8. 2x plus y is less than or equal to negative 4. The first thing that we need to do is rewrite this inequality in the slope-intercept form. We need to subtract 2x to both sides of the inequality. So now we have y is less than or equal to negative 2x minus 4. So the slope is negative 2 and the y-intercept is negative 4. To graph this, we will begin with the y-intercept negative 4. Now we need to graph the slope negative 2 over 1, which is 2 down and 1 to the right. Or the same thing as 2 up, 1 left, 2 up, 1 left, and so on. Since it's less than or equal to, that means the graph is a solid line passing through these points. Are we shading the upper half or the lower half? The lower half, because we have less than or equal to. Let's test the point negative 4, negative 4. Plugging in negative 4 into the inequality, we have 2 times x is negative 4 plus y is negative 4 less than or equal to negative 4. 2 times negative 4 is negative 8 plus negative 4, is it less than or equal to negative 4? Negative 8 plus negative 4 is negative 12 less than or equal to negative 4, which is a true inequality. So the solution set of question number 8 are any points below the line, including the points on the line. Question number 9. 3x plus 2y is less than 4. The first thing that we need to do is subtract 3x to both sides. So now we have 2y is less than negative 3x plus 4. Now we need to divide both sides by 2. Then the new inequality is y is less than negative 3 over 2x plus 2. This means that the slope is negative 3 over 2 and the y-intercept is positive 2. Graphing this inequality, we will begin with the y-intercept 2. The slope is negative 3 over 2, which means we need to go 3 down and then 2 to the right. 3 down and then 2 to the right. We can also go 3 up and then 2 to the left. Since it is less than, this means that we have a dashed line passing through these points. Are we shading upper half or lower half? We're shading the lower half because we have less than. So this is the graph of question number 9. Let's test the point 0, 0. Plugging in 0, 0, we have 3 times x is 0 plus 2 times 0 less than 4. And this is of course 0 is less than 4, which is a true inequality. So the solution set for this inequality are anything below the line, excluding the points on the line. Question number 10. 9x minus 4y is less than 20. The first step is to subtract 9x to both sides. So we will have negative 4y is less than negative 9x plus 20. The next step is to divide both sides by negative 4. Since we're dividing by a negative number, the inequality less than will switch to greater than. So now we have y is greater than 9 over 4x minus 5. So the slope is 9 over 4 and the y-intercept is negative 5. Graphing this, we will begin with the y-intercept negative 5. And the slope is 9 over 4, so we need to go 9 up and 4 to the right. We have y is greater than 9 over 4x minus 5. So this means that we have a dashed line passing through these 2 points. Are we shading upper half or lower half? We're shading the upper half because the inequality involves greater than. Y is greater than 9 over 4x minus 5. Let's test the point 1, 2. Plugging in 1, 2, we have 9 times x is 1, minus 4 times y is 2 is less than 20. 9 times 1 is 9, 4 times 2 is 8, is it less than 20? 9 minus 8 is 1, and 1 is less than 20, which is correct. So the solution set for question number 10 are anything above the line, excluding the points on the line. Thank you for watching, and please consider subscribing to my channel at Celzo Academy.